Hey beautiful people, welcome back to my channel. My name is Busisiwe Dlamini Harodi, the Campbell Principal. I am back again with another video. In this video, I want us to talk about serial dilution. So with serial dilution, it's when you make multiple dilutions whereby you try to decrease the concentration of the analyte while increasing the dilutions that you do, but by not going back to the original tube. And another important thing with serial dilution that you need to know is that they are dependent of one another. So if you mess up the first dilution, then you're going to mess up all the other dilutions that are going to follow afterwards. So it's very important to take care when you do the first one. So let's do an example on so that I can show you what do I mean by that. So let's say you need to do a 1 in 5 dilution and a 1 in 10 and a 1 in 15 dilution. So this is your patient. Then you will have tube number 1, tube number 2, and tube number 3. On tube number 1, you need to do a 1 in 5. On tube number 2 is a 1 in 10, and then a 1 in 15 on tube number 3. So the first dilution that you are going to do, it will be a 1 in 5, whereby you will have to take your solid from the patient's serum. So to do a 1 in 5, we know that, okay, with my serum, it has to be 1 part. So let's say you're going to use 1 ml of your serum. So from your patient's serum, you are going to take 1 ml. So now, to make a 1 in 5, if you can remember from the previous video, to know how much diluent you must use, you are going to multiply this 1 ml by 4. Because at the end, you must end up having a 5. So it means now for your diluent, it's going to be 4 ml saline. And then you're going to end up having a 1 ml serum. And this will give you a total of 5 ml. So in this case, you have done a 1 in 5 dilution. So now you need to do a 1 in 10 dilution. So the first question that you need to ask yourself is that already I have my first dilution, which is tube number 1, whereby I did a 1 in 5 dilution. So now I need to do a 1 in 10 dilution without going back to the original sample. So what you need to ask yourself is that which number can I multiply with the 5 to give me a 10? Because here already I have decreased the concentration of the analyte 5 times. Now I need to decrease it 10 times. So which number can I use or can I multiply with the 5 to get a 10? So that number, it will be a 2. So it means on tube number 2, I need to do a 1 in 2 dilution. So when you do a 1 in 2 dilution, it means you're going to have a 1 ml of your saline, and then you're going to take 1 ml from tube number 1 into tube number 2, which will give you a 1 in 2 in your tube. But then the solution dilution in this case is going to be a 10, because we are decreasing the concentration of the analyte 10 times. Again, going back, now you already have 2 tubes. Here you've done a 1 in 5, and here you've done a 1 in 10. So now you want to do a 1 in 15 dilution. So if you need to do a 1 in 15 dilution, you're still going to ask yourself, from the dilutions that I have, which is a 1 in 5 and a 1 in 10, between the two, which ones can I use? Let's say, okay, now you also need to use a 1 in 5 dilution. Then you're going to ask yourself, from the 1 in 5 dilution, which number can I multiply with 5 to make a 1 in 15, which will be a 3. But for our case, let's not make a 1 in 15. We will get to that one. Let's make a 1 in 20. Let's go higher. So on tube number 3, you need to do a 1 in 20. You're going to ask yourself, okay, I have tube number 1 and tube number 2. If I have to move from tube number 2 to tube number 3, I have a 1 in 10 on tube number 2 and I need a 1 in 20. You're going to ask yourself again, which number can I multiply with 10 to give me 20, which will be a 2. So it means as well in this case, you're going to have 1 mil of your cell line and 1 mil from your 1 in 10. From your 1 in 10, which will give you a 1 in 2. But what you have done, you have decreased the concentration of this analyte from this patient 20 times. Okay, let's do it like this. Let's say now you've done your dilutions. You ask yourself, okay, what is a tube dilution? What a tube dilution is, it's that dilution that you are doing practically when you are pipetting. So in this tube number 1, I have 4 mil saline and 1 mil serum. This gives me a total of 5 mils. So it means now my serum is 1 part over total volume, which is 5. So it means the tube dilution of my tube number 1 is a 1 in 5. Then when we get to this tube number 2, I have used 1 mil of my solute, which I got from tube number 1, and 1 mil of saline, which is my diluent. So these two, they give me a total volume of 2 mil, and this is my 1 part of a solid. So it means I've done a 1 in 2. The same thing on tube number 3, it means I have done there is a 1 in 2 as well, because it's 1 mil of my saline and 1 mil of my solution from tube number 2. So that's what tube dilution is. You've done a 1 in 5 practically, a 1 in 2, and a 1 in 2. So now let's talk about a solution dilution. Basically, what a solution dilution means is that we want that dilution, or the number of times you have decreased the concentration of the analyte. So from tube number 1, because you took your solute from the original sample and you've mixed it with 4 mils of saline. So it means the solution dilution is still going to be a 1 in 5, because you have decreased the concentration of the analyte from your patient 5 times. But now when we get to tube number 2, you have done the tube dilution is 1 over 2. But now you did not use 1 mil from the original sample. You have taken 1 mil from the diluted sample, the sample that is diluted 1 in 5 already. So now to get the solution dilution, you're going to multiply this by the dilution factor from tube number 1, which is 5. So it means here you have done a 1 in 10. That's the solution dilution. You have decreased the concentration of the analyte 10 times. And then when we get to tube number 3, yes, the tube dilution is a 1 in 2 again, but because I've taken my 1 mil from tube number 2, where I have done a 1 in 10, it means now I need to multiply my tube dilution with the solution dilution from the tube where I've taken the 1 mil, which is going to be 2 times 10. Then in this case, it means I've done a 1 in 20. It means the concentration of this analyte that is in the patient sample has been decreased 20 times. And then if you are being asked to write the total volume, so the total volume for tube number 1, it will be 5 mil. For tube number 2, it will be 2 mil. And also for tube number 3, it will be a 2 mil. So basically, that's what serial dilutions are. As much as you are doing a tube dilution, when you are reporting the patient result, you will report them, or you will multiply the result by the dilution factor of the solution dilution, not of the tube dilution. So when will you use this in the laboratory? You will use it in most of the cases whereby you have a little sample from the patient. So let's say you have received a baby tube for amikacin, and then when you run that amikacin need, you find that the result is greater than the measuring range. So when the result is greater than the measuring range, you follow your SOP. Your SOP tells you that if the result for amikacin is greater than, you need to do, let's say, a 1 in 5 and a 1 in 10, for example. So this is what your SOP is saying. Amikacin, when it's greater than, you have to do a 1 in 5 and a 1 in 10. So now what happens is that you have ran these two solutions. You've done them already. You ran them, but still the result comes out as greater than. But now you have a problem because there is little sample that is left in the baby tube, or there's no sample at all. So instead of asking for a replete, you can be a proactive medical technologist, whereby you can use the dilutions that you have already made to make higher dilutions. So let's say, okay, this is our 1 in 5, it did not work, and our 1 in 10, it did not work. Now you want to go higher. So when you go higher, you can do, let's say, a 1 in 15 and also a 1 in 20. So what you are going to do, because now you don't have any sample left, so you cannot pipette back from the sample. But what you are lucky with is that you still have your two dilutions that you have prepared initially. So to move from this, it means to make a 1 in 15, you can use the 1 in 5 dilution that you have made, and then you will say, okay, because I already have a 1 in 5, which number can I multiply with 5 to get 15? And that number will be 3. So it means now you will make a 1 in 3 dilution here, whereby you're going to use 2 ml of your saline and 1 ml, but that 1 ml, you will take it from your 1 in 5. And then you'll be having, if we were to calculate the solution dilution, you're going to have 1 in 5 multiplied by 1 in 3, which gives you a 1 in 15. So it means now you have decreased this concentration 15 times. The same with your 1 in 20. You will ask yourself, between the two, which one can I use? You can use a 1 in 10 as your solid, but then do a 1 in 2 dilution, or you can use the 1 in 5 and then do a 1 in 4 dilution. So let's use the 1 in 10. So to use the 1 in 10, I will mix my 1 ml of saline and 1 ml from the 1 in 10. So this gives me a 1 in 2 dilution. And then multiply by 1 in 10, it gives me a 1 in 20. And then now, when you are done, you're going to take these dilutions after you've mixed them, run them in your instrument. Then after you run them in your instrument, whatever result that you are going to get from this tube, you're going to multiply it by the dilution factor, which is 15. And then this one, you'll multiply by the dilution factor, which is 20. And then you're going to calculate the percentage difference, like I showed you in a previous video. And then if the percentage difference fall under the total allowable error for amikacin, then it means you can release those results, and then maybe you can release this 1 in 15 and enter your 1 in 20 as a checked value. Instead of asking for a replete, you manage to give out a result. That's what you will do. So then you will only have to, in this case, you'll only have to ask for a replete even if after you have made these dilutions, then your result, your total allowable error or your percentage difference does not fall within the total allowable error, then that's when you can ask for a replete. But actually, if it falls in, you would have saved a lot of time. You have saved the baby the pain from the blood being thrown and so on, and you are proactive. You manage to give out the result. So this is how you can use serial dilutions practically to make sure that they work for you. Basically, that's what I wanted to share with you, and hopefully it makes sense and you'll be able to incorporate this into your work if your SOP of the laboratory allows it. But this would be a nice thing to know and a nice thing to do, so that we are proactive and we are able to beat the turnaround time. Up until next time, until I meet you again, thank you so much. Bye.